This is Chapter 1, Network Security Overview. In this video, we are going to explain why we are concerned about security when we use internet. And in particular, we are going to look at some of the fundamentals in the internet that we are using today and why they cause security concerns. Okay, so why is security important? So when we talk about network security, we basically meant the security when we use internet to communicate with each other. Okay, so so if you see this bullet, first of all, internet is a public network. Okay, oh, sorry. And second, it is built on what we call TCP IP technology. In particular, this is a store and forward technology. And so now let me open up a separate screen so that we can draw something up here. Okay, so TCP IP technology. So this is it divides this architecture. So this network architecture is divided into 5 layers. Okay, at the bottom layer is a physical layer. So this layer transforms your content, so your binary strings, into signals for the underlying networks. For instance, if you're using fiber optics, that will become light pulses if you are using wireless network, and then the signals will be radio signals, and so that is the physical. So that's the physical layer. So let's say we have Alice, one of a user, and then the other user is Bob. Okay, so physical. So let's say this is a normal wired network. Okay, so this is connected. And it is, so normally if this Bob is far away from Alice, this connection is not a direct connection. Instead, it will go through, so this is the internet. So it will go through a bunch of routers. Okay, so this is router A, and then you may also need to go through router B. So you would need to go through a few routers, okay? And so now let's look, so these signals will go through these routers, and then this is a network layer. On top of it, on top of it is a data link layer. Sorry. So this is a data link layer, and then on top of it is a network layer. So that's where IP sits in. So that it's internet protocol. That's at the network layer. And then, oops, where did I go? And then this is a transport layer. This is transport layer notation. Okay. Okay, so this is transport layer. So the TCP sits at this layer, and also UDP. So these are traffic control protocol. So this IP is for forwarding packets. Okay, so this is for packet forwarding. Okay, then on top of this transport would be application layer. So for instance, email, okay, web, surfing, and maybe remote login, SSH. So these are the common applications. So of course, for web, you have you can do online shopping, that kind of thing. So on the other side, it's the same. So data link, network, and transport, and application. So this is Bob's computer, it's host computer. So this is Alice. So computer is called a host. And a router only has 3 layers, okay, physical, data link, and network. Because it's a packet forwarding, so when a packet gets into a router, it just checks its destination, and then it will forward to the next router. So one router may connect to different several routers, okay? So it may connect to other routers. All right, so so your email, for instance, you send an email, Alice sends an email to Bob, and that email, if it's long, then it will be divided into blocks, into data blocks. Okay, and then the data block will then be, so let's call this data block. Okay, let me erase this. Okay, so you got a bunch of data blocks because if the email is long, and then so when that data block goes down to the transport layer, so it will be just one block, one data block, and this is called payload. So that is one block. of application data. Okay, when it goes down to this TCP layer, what it does is to add a TCP header. So the TCP header is used to control traffic. So then it means that, so it has, the most important part is two things. One is a port number, the other one is a sequence number. So we got port number, and also has a sequence number. Okay, you further down, so these are in here. Okay, you further down to IP. So it passes it down. Okay, so let me start a new screen. So that we have a better idea. Okay, let's say now we are using email at the application layer, and this is TCP IP. Maybe let's do a web here. But that's okay. So let's say now is a network. This is data link. And this is a physical. Okay, so you got a bunch of blocks here. So this is a data blocks. You can't just send a very long email in one shot. So you got to divide these long email into blocks such that each data block can be encapsulated inside a TCP packet. Sorry, this is not IP here. This is TCP. All right. So let's say this block comes down to the TCP layer. Then what it adds is a TCP header. And this data block then is called a payload of TCP. So in the TCP header, there's a port number and there is a sequence number. Okay, the port number is used to indicate which program you are using. So you're using email, so you are either using SMTP or POP3, right? So these are the applications. You got a port number to indicate which one you are using, and then the sequence number is to link all these data blocks back. Okay, so there's this whole thing passes down to TCP. So this comes first, this comes second. So it needs a sequence number. At the destination, you can put them back in the original order because we are using store and forward technology. Some of the data blocks in a later part may come first, okay, may arrive first. So you need a sequence numbers to put them back. And also, in this header, it has other information such as sync. So this is for synchronization, and to go with synchronization, there is acknowledgement. So these these fields, if they are set, so it's used to indicate, okay, so this TCP is for synchronization, and the other, if this ACK bit is set, then it indicates that this TCP packet is for acknowledgement of SYN. So, so we have this idea of three-way handshake protocol. That's how connections are made. Okay, so then we need to forward this packet into to the destination. So that means I'm gonna pass it down to the network layer. So this part is the same. So this is a TCP header, and this is the data block. And then this is now we are adding a IP header. So this part is a payload of the IP header. So this is the payload of IP. Sorry, as a payload of the IP packet. So each of these is called a packet. Okay, so in this IP header, the most important thing, two things you need to forward this is, you know, the destination IP, and also you need a source IP address. Okay, so these are the IP address. So then this one comes down to the data link layer. What you are getting now. So you got IP header, you got TCP header, you got a data block, and then you got a frame header. So this now is called a frame. So let me put this IP. So this is the source IP address, and then we got a frame header, and also it comes a frame trailer. Okay, so a trailer tail. So let me use a trailer here. Let me use a trailer. Frame trailer. Okay, so so now this is hardware dependent. So depending on which IEEE 802 technology. Okay, so it's hardware dependent, so it depends on the underlying network you are using. And these three layers are logical layers. Okay, so which means that they are hardware independent. They are just software. Hardware independent. Okay, so then these will then become signals. So this is just will become signals, physical signals. So you need a beginning to indicate, okay, this is the start of a transmission of this particular frame. You need an end to indicate this is the end. Otherwise, they are all just signals. You don't know which one is the beginning, which one is the end. Okay, so you do need those. So this is physical signals. All right, so now let's move back. So now let's move back. So if Alice wanted to send an email to Bob, okay, so his email will go down in this direction. And then finally, this packet will go through using the internet technology. That means that the packet will first go to a router. So we call this intermediate router. And then depending on the destination, it may go through the next router here instead of going this router, right? Because this is further away. And then you keep going and then going to the last one, and then you go into Bob's machines. So when the signal goes to this machine, then it will first be converted back to a frame, and then it will convert it back to a network, to an IP packet, and then it will convert it back to a transport packet, TCP packet, and then you will convert it back, which means when you go through the network, you take off the header, you get a TCP packet, you take off the TCP header, you get the data block. So data block will go back to the application. All right, so basically that's how a packet is transmitted from the sender to the receiver. So now what we are interested in is this internet, right? So your packet goes to this router. But who controls this router is not Alice, okay? It's not anybody Alice knows, actually. So this will be controlled by a third party. You may not even know them, okay? So what that means is now because this internet router has these 3 layers, so which means that they will have your IP packet. Okay, so they have everything, right? They have everything. They can look at your IP packet, and they can also look at the protocol that packet is using, and hence anybody can see the payload of that packet. Okay, so again, this whole thing is a packet. This is a payload. This is TCP. This IP. So if the third party also install software to read this payload, then they can read it. So now we see the first security issue we are facing is that the email sent out from Alice to Bob can be seen by any intermediate routers here. And so you don't have privacy. And another one is that an attacker may be able to modify your packet. So let's say this is a bad guy. So this attacker gets your packet and he modifies the payload and continue to forward to the next router as if this packet comes from Alice. Okay, so you can see that because of this technology, so the things you sense through the internet is wide open. Okay, so this is like you open up, so you send a mail, and that mail can be read by anybody. Okay, so by any mailman, for instance. Okay, so this is a security concern, obviously. So that is why we need to have mechanisms to protect the information you send over or send through the internet. Okay, so that's what this course is about, what type of mechanisms we can use. So in order to address these mechanisms, so we will need first look at some of the common network security attacks, okay? And then we'll provide a network security overview in this chapter. So then after this chapter, we will talk about concrete security countermeasures, the mechanisms we use to secure network communications. Okay, so that is why network security is important.